Okay, we're going to look now at using dy by dx. Remember, dy by dx is the gradient of a tangent at a given point. So our first one then, find the gradient of each at the given point. So part A, y equals 7x squared plus 3x minus 1, and the point is 233. So when it talks about the gradient, you should be thinking dy by dx, so differentiate, get 14x plus 3, and then at x equal 2, you don't care about the y coordinate, it's just the x coordinate that we'll worry about. Dy by dx is going to be 14 times 2 plus 3, so that's 28 plus 3, which is 31. Part B, y equals 4x squared plus 1 over 2x, and the point this time is 9 over 2. So first thing we're going to do is rewrite our y to make it easier to differentiate. Okay, so by bringing the x up and it becomes x and minus 1, remember the 2 stays where it is. So differentiate, we get 2 4s are 8x minus a half x to the power of minus 2. And we can tidy that up a bit by bringing the x back down again. Okay, so the x to the minus 2 becomes 1 over x squared. And then we want to find out the value then at x equal 1. So that's 8 times 1 minus 1 over 2 times 1 squared, which is 1. So that gives us 15 over 2. Question 2, evaluate f dash of 2 if f of x is 3x squared plus x to the power of a half. So it's just using the different notation. So this is our function f of x. So the first thing we want to do is to find this f dash of x. So by differentiating, and we get 6x plus a half x to the minus a half. So then we'll want to find the value of it when x is 2. Now when you put that into your calculator, you get 12.4. Question 3, find the coordinates of the point on y equals x squared plus 4x minus 2, where the gradient is 2. So this time we're given the gradient, and we have to find x and then y to get the coordinates. So we'll still need dy by dx. So that's 2x plus 4. It says our gradient is 2. So we'll let that equal to 2, which means that x would be minus 1. So that's our x coordinate. We need to find the y coordinate then by putting it back into the equation of our curve. So y equals minus 1 squared plus 4 times minus 1 minus 2. That gives us minus 5. So our answer then, the coordinates where the gradient is 2, minus 1, minus 5. Question 4. If y equals 6x plus 2x cubed, find the coordinates of the points where the gradient is 12. So in question 3, we were just looking for one point where the gradient was 2, but this curve now has 2 points where the gradient is 12. So dy by dx, we get 6 plus 6x squared. We let that equal to 12 and solve it. Now we have a nice straightforward one to solve here. And we get that x is plus or minus 1. You may get a quadratic that you have to use the formula for or factorize into 2 brackets. So then when x is 1, y is going to be 6 times 1 plus 2 times 1 cubed, which is just 1. So that gives us 8. And when x is minus 1, y is going to be 6 by minus 1 plus 2 times minus 1 cubed, which gives us minus 1. So that's minus 8. So our answers then are 1/8 and minus 1 minus 8. Question 5, y equals 4x squared plus 5 minus x all over x. Find the equation of the tangent where x equals 1. So to find the equation of any line, you need a point on the line and you need the gradient. So let's start with the gradient. Right, I have to separate up the fraction there to simplify it. So we get y equals 4x squared plus 5x to the power minus 1 minus 1. Now we can differentiate and we get 8x minus 5x to the power of minus 2. So when x is 1, our gradient is going to be 8 times 1 minus 5 over 1 squared. So that gives us 3. We also need to find the y-coordinate. So put that into the equation of the curve. So it's 4 times 1 squared plus 5 minus 1, which is 4 over 1. So that gives us the y-coordinate as 8. Then put it into, this is where you go back to your coordinate geometry. Put it into y minus y1 equals m upon x minus x1 to get the equation. So y minus 8 equals, our gradient is 3 upon x minus 1. Multiply out your bracket and bring the minus 8 across and becomes a plus 8. So our equation is y equals 3x plus 5. So question 6, find the equation of the normal to the curve y equals x squared minus 4x plus 1 at the point 3 minus 2. So this time we're dealing with the normal, not the tangent. So we'll start it in the same way, differentiate, and we get 2x minus 4. Now when x is 3, so our x-coordinate is 3, dy by dx is 2 times 3 minus 4, so that gives us 2. Now that's the gradient of the tangent. Remember, the tangent and the normal are perpendicular, so that means the gradient of the normal would be minus a half. Then the equation we're given the y value. Our gradient is minus a half and our x coordinate is 3. Now, depending on how a question would be asked in the exam, you could leave it in this format, or more likely, we want you to tidy it up and leave it in the form of ax plus by plus c equals naught.